Hello, welcome back. Bit of an impromptu video tonight. I wasn't planning on doing a video today, but there's been a few earthquakes on the northern slopes of Alaska this morning. Part of the world I've become very interested in recently. As you'll know, if you've been following me latest videos, I've just come over to CAMS to have a look at the methane. We're at the Arctic visualization at the surface, and this is from last Thursday. We had a bit of methane coming up. We go on to Fridays, and there isn't any to see. And we go to Saturday, and there isn't any there on Saturday. And on Sunday, there isn't any there either. So as you can see, we haven't got a continuous stream of methane coming up from northern Alaska at the moment. If I fast forward this to 1200 hours UTC time Monday, you can see there's been, this is lunchtime today, it's showing a detection of a methane burst. To be entirely honest, I'm not sure whether this is actual or a forecast. You need a crystal ball to forecast methane eruptions anyway. Anyhow, I'll show you the earthquakes. I'm using USGS because we're in Alaska, and I've got the 30 days all magnitudes switched on. So this is the area on the northern slope where all the drilling's taking place and the methane's been coming from. I don't know whether it's all natural or whether it's man-made causes or a bit of both. Anyway, today, starting the first one, we had a 3.7, and it was quite shallow, at 1.9 kilometre depth. That was followed by one right at the surface, 0.0 kilometres, 1.9, some 4.5 hours later. And then a couple of hours after that, we've had a slightly deeper 2.7. Other recent earthquakes in the area on the 2nd of December. We had a 2.2 at 22 kilometres, nearer to the shore. And then another one right at the surface, 0.1 kilometres, a 3.4. Right on the surface. So what's causing these large surface quakes? Very unusual. And all the rest of them from the last 30 days. And we look at the depth. We've had another one though, 1.8 right at the surface. And another 2.6 at the surface. So I'm thinking, are these gas eruptions from the ground? Seems very unusual. I thought I'd look into it a little bit deeper, delve a little bit deeper. So going back to the 1.8 at the surface on the 30th of November last week, I wanted to see what the history of the area was. So I've done an advanced search. So I've search for either at the surface or maximum depth of 0.1 kilometres with a minimum magnitude of 1.8 to see how many others there's been in recent years. And I've done this search back to 2015 and there's only 28 came up, including the 3 most recent ones. A swarm began with a 4.1 at 0.1 kilometre depth on the 12th of August 2018. Nothing in 2016 or 2017 at all, and this was to the west of the little swarm that we're having. And then on the same day, an hour later, 3.5. These are all right at the surface, and an hour and a half later, a 2.5. And the following day, we had the largest one of the lot, a 4.4, which was right in the centre next to where today's earthquake's taken place on the 13th, and that was followed by another 1, 2, 3 more on the same day. Had a couple on the 14th, one on the 15th, and then they start to slow down a bit. One on the 18th, 19th, one on the 20th, 23rd, 24th, 29th, 5th of September 2018, one on the 10th, one on the 19th, one on the 22nd, 2nd of October, 13th, 14th, 26th, 28th, and after the 28th of October 2018, there was absolutely nothing until last week. And now we've had 3. So, are we witnessing the beginnings of another swarm of surface quakes? And is methane being emitted? Is it the methane being emitted that's causing the earthquakes? Or is the earthquakes allowing the methane to escape? As I've just shown you, the shallow earthquakes started popping up about August 2018. I was just wondering, could it be weather related? I'm going to climate reanalyzer looking at the temperature anomaly for back in February 2018. And there was I wouldn't say it was warm, but it was a hell of a lot warmer than what it should have been. These are extreme temperatures for the time of year. We're off the scale. Double figures Celsius above 0. So I'm thinking like the ground is the north slopes right in the middle of it. I'm thinking that during the winter the ground isn't freezing up as it should be doing, and then when the sun comes out in summer, it's just turning the ground's turning to slush. And we had this going on in the middle of the swarm during September 2018. A massive historic high pressure zone is bringing freakishly nice weather to Alaska. Alaska's experiencing some of the sunniest, warmest and driest early fall weather it has ever seen. In Anchorage, for example, temperatures have remained above normal for 32 straight days and it's hardly rained. And this is from the 2nd of October, so he's talking about throughout the whole of September. The cause is a massive area of high pressure at high altitudes known as a ridge, which formed over the Bering Sea in early September and drifted eastwards. Scientists who study the region's weather have never seen a high-pressure zone like this one. On a 2 to 3 week timescale, the recent ridge over the Bering Sea was one of the most intense on record anywhere in the world when compared to the usual climate of the region. Saturday afternoon, Fairbanks pressure, about 3 miles high, reached its greatest intensity on record so late in the year. Anchorage had its warmest September on record. Fairbanks posted warmer than normal temperatures for the last 20 days of September, and Nome for the last 22 days. King Salmon at 71 degrees, warmest temperature ever so late in the season. Bethel failed to observe any low temperatures below freezing in September for only the 4th time on record. And Chukotka, Siberia, posted its warmest September on record with an average temperature nearly 11 degrees above normal. I'm not talking about Siberia. The weather has been truly terrifying this year, tweeted Peter Stanton, a Ketchikan resident, gazing out over clear blue skies. I wonder what he thinks of 2020. In his analysis of the intensity of the responsible high-pressure zone, James found that it was 5.2 standard deviations above normal. We'd expect this kind of anomaly to occur less than once every million years on average. For this particular date window, James wrote, under the assumptions that the climate is static, which of course it's not, and his analysis is correct. So I was thinking, was this the second once every million years event? And did it happen again this year? So I checked on that too. Now I couldn't find any unusual high pressure systems in 2020, but I thought I'd just look at the average temperatures for the recent months, and this was for August. You can see we're in the darkish greens. Is the temperature scale down the bottom. We have a look at September's averages. Still just about just above freezing, and more recently in October, now we're getting down just below freezing. If you look at the temperature anomaly though for October, we could see that it should be much cooler than what it is, than what it was. We're looking at temperatures there, 5-6 degrees, well even 10 degrees above normal just off the coast. So the temperature should be well below freezing in October, but instead it was just averaging out around 0. So it's not freezing up properly. We haven't got figures in for November 2020 just yet. Oh, and by the way, NOAA's still not released their monthly methane figures for August. Well, I hope that wasn't too boring for you. I just felt I had to get on and talk about the shallow earthquake today. I'll keep watch and check to see whether that's the beginning of a new shallow earthquake swarm on the northern slopes. Just before I go,
I told you not to talk about it, Dave.